Welcome. In this lecture, we will talk about a very important concept, that is the difference between the terms variance, covariance and correlation. Now, before we dive into the details of these, let's understand why this difference would be useful for us. So, when we would understand covariance, then only we would be able to talk about the concepts like ANCOVA, MANOVA, which is analysis of covariance, multivariate analysis of covariance, and these are similar to ANOVA and MANOVA, analysis of variance and multivariate analysis of variance. Now, each of these we would discuss in the next lecture, the major differences and how do we understand that. To have that picture clear in mind, we need to understand these terms. Now, variance, we have been talking about it since long in statistics, and the idea is how much deviation is there from the mean, or how much variation is there from the mean is expressed as variance. Now, if it is more, then what does it signify? It signifies that the variance is more. If the values are small, then it signifies that the values are close to the mean or the average value. This is explained as variance. Now, when we talk about variance, variance is written as summation of x minus x bar the whole square divided by n. Now, here I take n as the number of items or the total data set, and this is a formula when we take the analysis of the population variance. However, if I am doing it for the sample, what would be the formula? Summation of x minus x mean the whole square divided by n minus 1. Why do I do n minus 1 here? Because I am actually taking the sample and I am removing the biasness of estimation from that sample, because here my n would again be representing the sample population. So, to avoid that biasness, what we do is we take the values as n minus 1. Now, this is what is variance. Under root of this variance would give me what? Standard deviation. And on the sigma plot, if you see, we mark down the standard deviation. So, these are the lines, one standard deviation away from the mean. So, 0 denotes the mean, which is x bar. Then you have 2 standard deviation and 3 standard deviation in the plus and the minus range. So, if I say mean plus minus 3 standard deviation, that gives me 99% of the values. That means 99% of the population would fall in this range, and this is what is variance. Now, we have well understood what is variance, but what about covariance? Covariance, from the covariance we can derive what is variance. So, covariance basically is between two factors. So, let's say I take factor x here and factor y here. Okay, the mean of the factor y is represented at this point. So, this is y mean, and the mean of the factor x is represented here. So, that is x mean. Clear? Now, when I take covariance, I am trying to find out the relation of these two factors. With covariance, I find the direction of relation. That means, if I say my x values are small and my y values are small, it would fall here. If my x values are big and my y values are big, it would fall here. So, it shows a positive relationship. In contrast to that, if I say when I have higher x values, I would have lower y values and vice versa. So, it would show a negative slope, or it would be a negative line, or there can be a circumstance where there is no trend. Whatever the value of x be, my y value would remain the same. For x is equal to 10, x is equal to 20, x is equal to 30, I have a value of y which is 30. It cannot change. So, there is no trend. So, with covariance, we say that either there is a positive trend or a negative trend or no trend. But covariance indicates the direction. Another important thing, let's dive into the formula for covariance. So, it is summation of x minus x bar multiplied by y minus y bar, which is the mean, divided by n minus 1. So, I know the value of I'll change the color here for clear understanding. So I know the y mean and the x mean. Now let's say my actual value of y that I'm trying to take is less than